in that we are now including the Kpack package in TCE. And we are very excited about that. And so to that end, we have with us Tom from Kpack, from the Kpack team, to talk about Kpack and do a demo for us.
All right. So for those of you who don't know, Kpack is a Kubernetes native way to execute builds of your application using cloud native build packs. That's in its simplest form, kind of what it is. So we just went through the whole process of getting Kpack in TCE, and I'm just going to kind of demonstrate basically the tutorial that we have in our README, just kind of talk through how that works. So I'm going to share my screen. Okay, so this tutorial has one prerequisite, which was installing TC itself. I didn't want to go through that whole process because I'm assuming everyone here is fairly familiar with that, but I did go through the upgrade process that's posted to upgrade the TC repo to 092. And that's where we are with that. So the first thing now that we can see is the Kpack package should be right around here. So you can, that's all included. So to install Kpack, there's a few values that we recommend users provide, and they're kind of centered around using our KP CLI, which makes things a little bit easier to interact with Kpack instead of just using kubectl, though you can just use kubectl. So the values I'm going to pass in are for our KP default repository, and this is the repository that our CLI is going to use to relocate images to. So when I create various resources for Kpack, it's going to relocate those images to my repository, and then the username and then the password I left out for now. The actual file I use will have it. That's all you need. I mean, technically you can just get going without any values, but this will give you a little bit better of an experience. So we're going to go ahead and install Kpack. So some things happening here.
Do you want us to wait on questions?
No, interrupt with questions whenever you want.
Okay. What happens if you don't put in any values? Like, what does it do? Where does it put things?
So when you try to use KP, it'll yell at you saying that it doesn't have the default repository set. And at that point, you can set it using the KP CLI. There's a command called kp config default repository and kp config default repository service account, which will allow you to set that later. But it does involve you like doing a little bit like creating the service account. You could also update your values at that point and then just run, Tanzu package update. But you can use Kpack without setting any of these. If you were to just use kubectl, it would not relocate anything to your own registry. You would just like reference like build packs and stuff like that where they live. And then when you create a builder, because a builder is an actual image that gets relocated, you would just have to make sure there's a secret present on the cluster builder resource that you create, which I can talk about when we get to that. So what I'm doing here is just a standard Tanzu package install with our Kpack package version 050, which is the latest version of Kpack. I just picked an arbitrary namespace and I'm passing in my values file. So this should only take a minute or so. By the way, if anyone is interested into even deeper dive of kind of what I'm doing now, is yesterday, Cora gave a talk on Kpack and TCE, but also went through a lot of like the entire cloud native build packs kind of ecosystem and how we got to where we are today. And I recommend taking a look at that. If it actually looks like there's a link in the HackMD. So definitely worth checking that out. Okay, so we have our Kpack package. Let's just make sure it's running. We'll just make sure the 2 pods in the Kpack namespace are running. So we have our Kpack controller and our Kpack webhook. These are the only 2 pods that run for Kpack, like our controllers and our webhook. And next, we're going to start creating some of the resources that are needed to run Kpack. So we have Cluster Store. Cluster Store is effectively a store for build packs that are referenced by builders, and they're used to actually execute these builds on the cluster. There's build packs for a ton of different languages, and you can also write your own build packs, but the method for which you'd add them in Kpack is actually creating something called a cluster store. So I'm going to run kp cluster store save. There's also a create command, but save does create or update, so it's a little bit easier. And I'm going to pass in one build package. I'm using the Paketo build packs project, and I'm going to pass in the Go build pack. I could have left off the digest at the end, but for later in my demonstration, I wanted to pick a specific version of the build pack for us to add to the store. And what it's going to do now is relocate the build pack. I went ahead and relocated these earlier just to save some time on the relocation, because I find the projects registry isn't always the fastest with like the relocation. But that's pretty much the process. And if we looked, we could see KP cluster store status default, and see we have our Paketo Go build pack version 0.13.0, which is not the latest version, and its status is ready. So we'll continue on to our next resource, which is the cluster stack. The cluster stack provides 2 images. It's the run image and the build image, which kind of make up the base operating system for our images. So the build image is what actually the builds are executed on. It's the base OS for the builds. And then the run images is a much smaller image that only kind of has what you need. This is the equivalent of if you do like a Dockerfile build and you like have a build image, and then you reference it when you actually like copy, say, like the jar out into your final image. And it's really just to, 1, have a smaller image so it's easier to pass around, and 2, minimize like attack vectors in packages. So we want the least amount of packages we can get into the final image where it's still runnable. So I'm going to create a cluster stack, and I'm going to run it on what is called the tiny stack from the Paketo build packs project. And this is a very small footprint stack. It only supports a few languages. I think it supports Java, Go, Java native image, and maybe one other. And I purposely picked version 1.3.18, which is a couple versions old, for later in my demonstration. And just like the cluster store, I pre-relocated these just to save some time right now, but it's just going to attempt to relocate them anyway, but the registry should let us know that they're already there. And
hey, Tom, sorry, before you keep kind of going on, sorry to interrupt you. Could you give like a one-liner about what is Kpack to some of the folks who might be new to Kpack and build packs in general? That could be kind of just helpful of what it is.
Yeah.
Before we keep going.
So Kpack is a collection of custom resource definitions and controllers that allow you to build OCI compliant container images for your application. So like source to image. It's basically a platform implementation of the cloud native build packs project, running natively on Kubernetes. There's also the cloud native build packs project has like the Pack CLI for you to execute the same types of builds locally on your machine, but this is designed to be run at scale, and you can have a lot of users doing this at the same time. Is that kind of what you're looking for? Is there any other questions about that?
I think he asked also why should I care about an OCI image? Like what's the go back one even level higher. I think he's trying to understand.
Yeah. So I think the reason you would care about that is, as just like an industry, everything is kind of moving towards, you have a lot of services that you want to deploy on a cluster, as opposed to like setting up a one-off VM that's going to like run your jar file, and you like, wrote some script that's going to like set up that VM and then deploy your Nginx server and run your Spring Boot app or whatever. Containers allow us to have a reproducible environment for our applications, where they're going to be the same, whether they're running on my personal machine, my personal cluster, or in GKE or AWS or what have you. So it allows us to kind of pass around this like very identical, reproducible build of our application without all that overhead that you would if you were managing VMs. Also kind of better utilizes resources too, where I can get a whole bunch more containers on the same hardware that maybe before I had one VM per application and I wasn't utilizing it. It was kind of like the next logical step after we had servers, and then we took VMs and we're able to break apart that hardware more. And now with containerization, we can get even more out of our existing hardware. Is there any other questions? Okay, so we just created a cluster stack. And if we look, we should be able to check that out, and it is ready. And as you can see, we did relocate these images. These originally lived in the Paketo Build Packs Docker Hub, and now they're living in my private registry. So we don't have to worry about if Docker Hub is up or anything like that. It's in our registry now, and it's kind of under our control. So the next thing we're going to do is create a cluster builder. And a cluster builder it's a few things. It contains our stack. It contains our build packs, and the build, so it knows which build packs to use. It has this thing called an order, which will define in which order we attempt to run our build packs. And I'll show you the status of the cluster builder, where we'll actually break down exactly how those build packs will be applied. And it also contains what's called the life cycle. The life cycle is like your standard implementation of the Cloud Native Build Packs project, where it has multiple stages that will run and execute a container build. So it will take the source, it will run. Every build pack has what's called a detect phase and a build phase. It'll run the detect phase for every single build pack against the source to determine if that build pack should participate. And it'll come up with a plan for the build. It will check to see if there is an existing image, an existing built image that it can use as a like cache to speed up the build process. And it will then restore that. Then we'll actually execute the build process. And then finally, it will take that finished image and it'll export it to the registry of your choice. So that's that. All that code for the lifecycle also lives in the builder. So the builder itself is an image. And how you create a cluster builder is you just give it a name, a tag where it's going to live, because like I said, it's an image, a stack and a store. And then this -- build pack is actually me defining the order. If I had more build packs in my store, I could provide more build packs, or I could say, I have 50 build packs in my store, but I only want this builder to be a Go builder. So I'm only going to provide this cluster builder with the Go build packs to keep it small and keep it dedicated for what I want to use it for. It allows you to have that kind of flexibility. So what it's going to actually do right now is create this image for the cluster builder and put it in my registry. And then we create the resource on the cluster. So we have, it's already, and this is where it's living. And then I pass in the Go build pack, but the Go build pack is actually multiple build packs. It's what's called a meta build pack. So it creates this order. Whenever it runs now, it is going to execute one build pack in, after another and figure out which ones are going to participate. If you'll notice, like we have like dep and go mod, we're not going to be using both of those at the same time. So we'll see as we do a go build that certain build packs will participate while others will not. So the next thing we have to do is create a secret for the actual image that we're going to create to use to be able to publish to the registry of our choice during the export phase. I'm going to be pulling from a public GitHub repo, but if it was a private one, I would also at this point create a secret to pull my private Git source. You could also use a blob image, a registry image, and then if you're using the KP CLI, you can actually upload like a local path source. Like if I'm just working locally on my project, I can just upload my source directly. It doesn't have to be committed yet. Maybe one other thing to call out is I mentioned the Kpack CLI before, and that allows you to execute builds locally. You can actually take any builder from Kpack and use it in the Kpack CLI. So you can have these reproducible builds both locally and on cluster. So I'm going to create a secret for my registry with my user. Normally we'll ask for the password, but I exported it as an environment variable before just to kind of keep it private. And now we're going to create an image. So we're going to create an image with this tag. We're going to pull from the Paketo build packs samples project at this particular Git revision. And the subpath is just where in the repo I actually want to build, because this repo has a whole bunch of code in it with my cluster builder. And then -- wait is going to actually wait for the entire build to execute. So we're pulling down the source. And now we're going to figure out if there's anything that we need to restore from any previous builds. And then the detect phase, if you can see here, 4 of 8 build packs participating. This is a go mod project, so dep isn't involved. The CA certificates build pack always participates, and what that allows you to do is inject custom CA certificates into the application so that they can trust any, like, say, self-signed server that you have in the running application, and you can do that by providing a mounted secret at runtime, and it'll then automatically load that CA certificate for you. So that's why you see the CA certificates build pack, that always participates. So it then did the export, and then it saved our image. And if we look here, we have one image that got a little cut off there because of my font size, but the important thing to see here actually is this reason. So the reason this build number 1 executed was configuration. I actually just created the resource. So it always does an initial build on configuration of the resource. But what if I want to patch an image? I say there's a new commit that I just pushed and I want to build that. I can run a KP image save passing this new revision, and it should automatically kick off a new build. And if you see here, the reason is actually commit now, because it has detected a change in the source. There is a way to just have it monitor a branch, but we typically recommend like doing Git revision, and you would do something like you push a commit to the repo, maybe run some unit tests, and then in CI do a KP image patch. We also have a concourse resource you can use to patch that and then build your image. So maybe do like a little pre-testing before as part of your development workflow. You see here, we're reusing some layers from the previous image to make the build faster, and it exported build successful. So now we should have 2 builds, and with 2 different reasons and 2 different images. But then what if I want to update a build pack? A new version of Go comes out and I want to use it. So what I can do is actually add this new build pack to my cluster store. And by default, any image that was using this build pack will rebuild. So if I had a bunch of images, we would see them all. Okay, sometimes it takes a second to actually create the build. There we go. Yeah, so you can see here the version changed and the build reason is actually now build pack. And we have a different version of the build packs participating. So this would simulate if there was a CVE and Go and the Paketo team released a new version of the build pack, we would want to make sure our applications get updated. You'll know it does have to go through a full rebuild process because we're actually trying to change the application source code. What I'm going to demonstrate next is actually like what I would consider one of the more powerful features of Kpack, which is rebasing. So how we have what's called like ABI compliant images, and what that means is basically if there is an update to the underlying OS, say Ubuntu is patched with a critical CVE, and I have 50 apps, 50 images that are being built using that base OS, and I want to patch all of them. In traditional Docker file land, you would have to rebuild all of them. You have to change your from statement, and that would, because that's changing the base layer of the from, everything after that, every single layer has to be rebuilt. How CNB images are built is they don't actually use that traditional layer structure. There is a separation between the base OS and the application layer. So if I update my stack with, say, a new version of the build and run image patching some CVE, that'll upload. Every single image will know that now. But the cool part is we can actually swap out the base OS without recompiling the application at all. So it ends up being incredibly fast. And if you look here, it's going through a rebase, so it's going to load the secret, and then that's it. All it does is it takes the layer for the new OS, slaps it underneath the old one, and then pushes that as a new image. And it can do that for thousands of images at once if you have a very large deployment. So that's something that allows you to keep your images up to date against any like critical vulnerabilities or stuff like that. Any questions?
There have definitely been a couple of threads going on in the chat, and we are running low on time. So how can folks find you if they need to connect with you after this? So I imagine you're in our Slack channel that folks can post questions. I'll let you.
Yep.
Okay. And do you all have any like other resources that you want to turn people to? Some docs or a link to this demo or something like that?
I can publish this demo somewhere.
Okay. Yeah. As Kartik said, we can start some threads in the Tanzu Community Edition channel in the Kubernetes Slack workspace.
Yeah. We do also have a Kpack channel in the Kubernetes Slack. If anyone is interested in the project or wants to learn more, we're happy to talk about it.
Awesome. Thank you.
Thank you.